So welcome students with the new part, that is the error function. So what is the definition of error function here? The error function of x is denoted by ER f of x and is defined as 2 by root pi integration from 0 to x e raised to minus t square dt for x is greater than or equal to 0. So this is the definition of error function. So it is denoted by ER of f of x, means error of f of x, and that is equal to 2 by root pi integration 0 to x e raised to minus t square. So very interesting, it suppose I want to find error function of p, that is equal to 2 by root pi integration 0 to p e raised to minus t square dt. This integrand is same, even though this 2 by root pi also same, only that is the error function of what, that is 0 to that. So error function of x integration 0 to x, error function of x square integration 0 to x square, error function of root x integration 0 to root x. So remaining part is as it is. It means that here 2 by root pi and e raised to minus t square dt, it will be same, only this will be changed, that is integration 0 to x. Here sometimes in some book you will find this variable different, that is instead of t there may be u. So don't confuse, because in definite integral, for example here a to b f of x dx, that we know integration from a to b f of t dt. So we can change variable without changing the limits. Also the complementary error function. So what is the definition of complementary error function? Complementary error function is denoted by ER f, here suffix c x, and is defined as 2 by root pi integration x to infinity e raised to minus t square. You can observe here error function and complement of error function. Here the notation change, that is a error function f of x, ER f of x, and here f of x but complement due to that suffix c there. Remaining 2 by root pi and e raised to minus t square is same, and here complement then x to infinity. Suppose I want to find complement of error function of x square. So integration will be here x square to infinity. Complement of error function of root x, it will be root x to infinity. So like that. So remember here the definition of error function and the complement of error function. So let's consider some examples on these, along with some properties of the error function and complement of the error functions. Very important properties are there. So let's start. First, consider the properties of error function. So which are the properties? So here you consider as an example, that is prove that error function of x plus complement of error function of x equal to 1. So how? The solution here, by definition of error function and complement of error function, we can write error function of x plus complement of error function of x equal to 2 by root pi integration from 0 to x e raised to minus t square dt plus, now the definition of complement of error function, it is nothing but 2 by root pi integration from x to infinity e raised to minus t square dt. So same thing I can write as integration from 0 to x. So this constant 2 by root pi you consider inside. So 2 by root pi e raised to minus t square dt plus integration from x to infinity 2 by root pi e raised to minus t square dt. As we know the property of definite integral, integration from a to b f of x dx plus integration from b to c f of x dx, that is equal to integration from a to c f of x dx when a is less than or equal to b is less than or equal to c. So here a to b and same here b to c. Now you can see here, that is here integration from 0 to x and here x to infinity, and here integrand is same, and therefore by using this property I can write that is equal to integration from 0 to infinity 2 by root pi e raised to minus t square dt Now evaluate this integration. So how? So constant term, that is a 2 by root pi, you take outside, and integration 0 to infinity e raised to minus t square dt I am getting. So definitely it suggests us t square equal to u. So what is the value of t here? So I am getting t equal to u raised to half, taking square root of both sides, and that is why it is the dt equal to 1 by 2 u raised to minus half du. So you can check the limits here from t to u, given limits 0 to infinity. So as a t equal to 0, I am getting u equal to 0, and t is infinity, u equal to infinity, and that is why I am getting u equal to 0 to infinity, means no change in the limits, and that is why I am getting here left hand side is what? Error function of x plus complement of error function of x, and that is equal to 2 by root pi outside, integration no change in the limits, but now e raised to minus t square, it becomes minus u, and dt is nothing but 1 by 2 u raised to minus half du. So take constant term outside, means now only simplification. I am getting here 2 by root pi into 1 by 2, it's a constant, integration 0 to infinity e raised to minus u and u raised to minus half du. Now evaluate this integration, but how? By gamma function. So do you know gamma function? So by definition of gamma function, gamma n equal to integration 0 to infinity e raised to minus x, x raised to n minus 1 dx. So you can see here whatever the power e raised to minus x and whatever the power of x, power plus 1 here. So now by using this gamma function you simplify. Before to that, if this 2 and 2 get cancelled, and outside 1 upon root pi as it is, this is the constant. And now about this integration, if we compare with this gamma function, so I am getting here by using gamma, it's a gamma of 1 by 2 because power plus 1. So by standard value of gamma function, gamma half equal to root pi, and that is why I am getting here 1 by root pi into root pi. So this root pi and this root pi get cancelled, I am getting 1, and therefore the result is what? Error function of x plus complement of error function of x, and that is equal to 1. So note that here by using this property, one can write a note as error function of infinity equal to 1. How? As by definition of error function of infinity is nothing but 2 by root pi integration from 0 to infinity e raised to minus t square dt. And you know what is the value of this? You can see here. Once we have 2 by root pi integration 0 to infinity e raised to minus t square dt, by solving this way I am getting that is equal to 1. So now the new property, prove that error function is an odd function. Also deduce that complement of error function of minus x minus error function of x equal to 1. The same question one can ask as, prove that error function of minus x equal to minus error function of x. So what is the meaning of this? Error function is an odd function. So solution. So you should know what is the odd function. F of minus x equal to minus f of x for all x. Means f of x is said to be odd function if f of minus x equal to minus f of x for all x. So it means that here error function of minus x equal to minus error function of x, we want to show this one, means it is a odd function. So by definition of error function, I am getting error function of minus x equal to 2 by root pi integration 0 to minus x e raised to minus t square dt. Now this minus x, I want error function of x, it means that I want 0 to x here. So what should be the substitution? it suggests us substitution is this variable t equal to minus u, and therefore dt equal to minus du. Now what about the limits? Here limits from t to u. Limits of t are 0 to minus x. So put here 0. So I am getting u equal to 0. And if t equal to minus x, so what is value of u here? This minus minus become plus, and I am getting limits that is equal to x. And therefore I am getting here 2 by root pi, this as it is, this is a constant term. Now limits 0 to x e raised to minus now t square. Note that as a t equal to minus u, so what is the t square? It is equal to minus u whole square, and that is equal to u square. So here I am getting e raised to minus u square, this minus as it is, and this t square I am going to put u square. And what about dt? I am getting minus du. So simplify this, take constant term outside. So minus there, so I will take it is totally outside. So inside 2 by root pi, integration from 0 to x e raised to minus u square du. And by definition of error function, I am getting it is equal to minus error function of x e raised to minus u square du. This is the integrand, and 0 to x it decide it is a error function of x, and therefore I am getting here this left hand side is error function of minus x equal to minus error function of x. This shows that error function of x is an odd function, hence proved. Now we want to deduce something extra. What is it? Deduce complement of error function of minus x minus error function of x equal to 1. So interesting it is. As we know by property of error function of minus x plus complement of error function of minus x equal to 1. Now we have the result error function of minus x equal to minus error function of x, and that is why I can write this is a minus error function of x plus this as it is complement of error function of minus x equal to 1. Same thing I can write as complement of error function of minus x minus error function of x, and that is equal to 1, which we want to prove. Now next, prove that complement of error function of x plus complement of error function of minus x equal to 2. It's very simple. As we know, property of error function of x plus complement of error function of x equal to 1. It means that error function of any plus complement of same, that is equal to 1. This is equation number 1. Now same thing I can write as for minus x. It means that error function of minus x plus complement of error function of minus x equal to 1. But now again second property of the error function, that is the error function is an odd function, means since error function of minus x equal to minus error function of x. So you put this value here, so I am getting minus error function of x plus complement of error function of minus x, and that is equal to 1. So this is equation number 2. So if we add equation 1 and equation 2, so what we get? This and this get cancelled because plus and minus sign there only. Now this plus this, that is equal to 1 plus 1. So adding equation 1 and 2. So it gives complement of error function of x plus complement of error function of minus x equal to 1 plus 1, that is equal to 2. So which we want to prove. So result is now error function of minus x plus complement of error function of minus x, that is equal to 2. Hence proved. So by using these properties, we can note as error function of minus infinity, that is equal to minus error function of infinity, and that is equal to minus 1. Also, by the definition of error function of x, we can write error function of 0 equal to 0. Why? Because by definition 2 by root pi integration from 0 to 0, and that is nothing but 0. As we know, by property, error function of x plus complement of error function of x, and that is equal to 1. So therefore, I can find out the different values of complement of error function of x. Like that, complement of error function of infinity is what? As error function of infinity is 1. So what is the complement of error function of infinity? I am getting it is a 0. Also, complement of error function of 0 is equal to 1, and complement of error function of minus infinity, that is equal to 2. So by using these different values, we can plot the graphs of error function and complement of error functions. How? Let's see. So here example plots the graphs of error function of x and complement of error function of x. So very simple way we can plot these graphs. As we know, the value of error function of 0, that is equal to 0. Error function of infinity is equal to 1. So it means that from x equal to 0 to infinity, we will get the values of 0 to 1. For example, so here, so this is the x axis, this is the y axis. So when x equal to 0, so here it's the origin 0 0, and as x here will get that x, and y means here now error function of x. So values of y means error functions 0 to 1. So supposed to be here 1, it is a 0 comma 1. So this value, so this is y equal to 1. So value of error function of 0, it is a 0, and error function of infinity, it is 1. Means from 0 to 1 we have to join smoothly. So I can join like this, I am getting like this. So at infinity the value will be 1. It is not at this. At infinity the value will be 1. So at infinity our curve and this dotted line will touch to each other. Since one more thing we know, that is the error function of minus x equal to minus error function of x. It means that error function is an odd function, and we know for odd function graph is symmetric in opposite quadrant. Means in the first quadrant I am getting this one, means same thing I will get, means symmetry in third quadrant. So how? Let's see here. Here supposed to be minus 1, y equal to, so this dotted line is y equal to minus 1 now, and this symmetry, try to maintain symmetry here. So I am getting like this graph. So this is the graph of error function of x, or y equal to error function of x. Now what about the complement of error function of x? So by using these values, I can write here as a error function of x plus complement of error function of x, that is equal to 1. So by using these values, complement of error function of 0, that is equal to 1. Complement of error function of infinity, that is equal to 0. Also, what is the complement of error function of minus infinity? As the error function of minus infinity is a minus 1, and that is why that is equal to 2. Now draw the graph for y equal to complement of error function of x. So here this is the x axis, here y axis, here origin. So at origin we want y equal to 1. Complement of error function of 0 is 1. Complement of infinity, it is 0. And complement of error function of minus infinity is 2. So here 1, so here I am getting 2. So from 2 it will start. So I am getting the graph is like this, because maximum value is now 2 and the minimum value is 0 I am getting. So note that here this dotted line is y equal to 2, because maximum value you can see here it is a 2 and the minimum value it is nothing but 0. So along this axis it is x and along this axis it is a complement of error function of x. So such type of graph I am getting here. It means that I am getting graph of error function is like this and graph of complementary error function is this one. Note the case. Now next, so example, prove that integration 0 to t error function of ax dx plus integration from 0 to t complement of error function of ax dx equal to t. So very simple way you can prove this one. How? So here integration 0 to t error function of ax dx plus integration of 0 to t complement of error function of ax dx, and that is equal to. So as a property of definite integral, which property? Integration from a to b f of x dx plus integration from a to b g of x dx I can consider as integration from a to b f of x plus g of x together under one integral into dx. So by using this property I can write here integration 0 to t error function of ax plus complement of error function of ax into dx. Now again the property of error function of x plus complement of error function of same, that is equal to 1, and therefore I am getting integration 0 to t error function of ax plus integration 0 to t complement of error function of ax dx, and that is equal to integration 0 to t I am getting here 1 into dx. So integrate it. So integration of dx is x, lower limit 0, upper limit t. So that is equal to upper limit minus lower limit, that is equal to t, and therefore integration 0 to t error function of ax dx plus integration 0 to t complement of error function of ax dx, that is equal to t, which is our result. So consider new example here. Show that integration from a to b e raised to minus t square dt equal to root pi by 2 into error function of b minus error function of a, given that a is less than 0 and b is greater than 0. So how to prove this one? So if we observe this thing, so what we know? We know the definition of error function, and that is why I will consider here the right hand side first. So solution here, so consider the right hand side, root pi by 2 error function of b minus error function of a, that is equal to root pi by 2, and by definition of error function it is a 2 by root pi integration from 0 to b e raised to minus t square dt minus 2 by root pi integration from 0 to a. Note that here definition of error function of a e raised to minus t square dt. Now common out here 2 by root pi. So root pi by 2 as it is there, and here common terms 2 by root pi. So inside I am getting here integration from 0 to b e raised to minus t square dt minus integration from 0 to a e raised to minus t square dt. So this 2 get cancelled, this root pi get cancelled, and I am getting the results integration 0 to b e raised to minus t square dt minus integration 0 to a e raised to minus t square dt. Note that what we want single integral a to b, and we have integration 0 to b and 0 to a. So how to collect together? So by using the properties of definite integral. So which properties we have to use here? So two different properties we have to use. So properties of definite integral, since integration from a to b f of x dx, suppose I want to interchange the limits, means lower to upper and upper to lower, minus sign outside. So minus integration from b to a f of x dx. Also we have to use one more there, integration from a to b f of x dx plus integration from b to c. Note that here a to b and here b common. F of x dx, that is equal to integration from a to c f of x dx. So by using this property we can prove what we want. So I am getting here left hand side as it is, that is the root pi by 2 in bracket error function of b minus error function of a equal to integration from 0 to b e raised to minus t square dt. So this minus sign I will adjust here. So due to this minus sign, limits will be interchanged like this. So plus integration from a to 0 e raised to minus t square dt. Now integrand is same for both integration, and that is why same thing can I write the second term first, means integration from a to 0 e raised to minus t square dt plus integration from 0 to b e raised to minus t square dt. So what I am getting here? So I am getting here by using this property a to b and b to c integration, I am getting integration from a to c, and therefore I am getting here integration from a to b e raised to minus t square dt. So what we want to prove here? Integration from a to b e raised to minus t square dt. Yes, same thing here I got, only I will write the left hand side integration from a to b e raised to minus t square dt equal to under root of pi by 2 into error function of b minus error function of a. Note that here a is less than 0 is less than b, because a is less than 0 and b is greater than 0, means I am getting here a is less than 0 is less than b. So which is our required result. So consider new example now. Prove that integration 0 to infinity e raised to minus x square minus 2ax dx equal to root pi by 2 into e raised to a square into 1 minus error function of a. So how to prove? See there, it's a relation with error function of a. So if we see in the definition of error function of a, I want the integrand is e raised to minus t square. It means that I want perfect square of this. So that is why solution as integration from 0 to infinity e raised to minus x square minus 2ax into dx, that is equal to, so I want a perfect square of this. So if we consider this is a minus x square minus 2ax, what should be the third term? If we common out here minus sign, so I am getting x square plus 2ax. So definitely the third term is a square. You can observe it is a perfect square as x plus a whole square. So what is additional I want? I want this a square. It means that if we multiply inside, so minus a square I want additional. And that is why the adjustment is integration 0 to infinity e raised to minus x square minus 2ax minus a square I want, and I can consider it is a plus a square into dx. and that is why I can separate it, integration 0 to infinity e raised to minus x square minus 2ax minus a square into e raised to a square dx. So here integration with respect to x, that is why e raised to a square is a constant, so outside, and inside integration 0 to infinity e raised to, now this is a perfect square, if we common out minus sign, of x plus a into dx. To consider the definition of error function, I want here a single variable t, and that is why you substitute x plus a equal to t. So what is the dx here? So therefore this implies that x equal to t minus a, and therefore dx equal to dt. What about the limits from x to t? So given limits of x are 0 to infinity. So if we put here x equal to 0, so I am getting value of t is a, and when x equal to infinity, so I am getting value of t equal to also infinity, and therefore integration 0 to infinity, left hand side as it is, that is the e raised to minus x square minus 2ax into dx, that is equal to, now using substitution here I am getting e raised to a square, integration now a to infinity e raised to, so minus x plus a whole square, so that is equal to t now, so minus t square into dx, so that is nothing but dt. So if we adjust here, as you can see there, this one, so you can see this one, that is the integration a to infinity e raised to minus t square dt. You can relate the definition of complement of error function. So what is that definition? So as a definition of complement of error function of a, that is equal to 2 by root pi integration a to infinity e raised to minus t square dt. So what is the required thing here? So 2 by root pi is not there. So I can adjust that it is a constant term, and that is why I can do like that, e raised to a square into 2 by root pi integration 0 to infinity integration a to infinity e raised to minus t square dt. So I am taking here additional 2 by root pi, and that is why the adjustment is outside root pi by 2, and therefore by definition of complement of error function, I am getting that bracket is nothing but complement of error function of a. So by using a property of error function, that is the error function of x plus complement of error function of x, that is equal to 1, and therefore I can write complement of error function of x equal to 1 minus error function of x. So by using this property, I can write that is equal to root pi by 2 into e raised to a square into 1 minus error function of a. I think we want to prove the same. Let's check here. So we want to prove the same. The left hand side is nothing but integration 0 to infinity e raised to minus x square minus 2ax into dx. So this is our required result. So new example, prove that d by dx of error function of ax equal to 2a by root pi into e raised to minus a square x square, and hence show that d by dx of error function of ax raised to n equal to 2an upon root pi into x raised to n minus 1 into e raised to minus x raised to 2n into a square. Actually, if you observe here, that is this one and this one. So this is the general term, because here a x raised to n, here a x raised to 1. So that is why I will prove second part first, and by using second part I can prove the first one. We want to find this value first. So d by dx of error function of ax raised to n, that is equal to d by dx of error function of ax raised to n. By definition, it is nothing but 2 by root pi equal to d by dx into 2 by root pi into integration from 0 to ax raised to n. Note that here we want to find error function of ax raised to n into e raised to minus t square dt. So that is equal to d by dx of integration 0 to ax raised to n 2 by root pi into e raised to minus t square dt. I am taking this constant term inside. So derivative and integration together. So how to evaluate it? We know if together derivative and integration, then we have to use DUIS. So here definitely t is a variable and here we have to take derivative with respect to x, means x is a parameter. So actually here parameters are a and x, but we have to take here to find d by dx x as a parameter. As the limits contains parameter, therefore we have to use here DUIS rule number 2, means Lebnitz rule. So what is the Lebnitz rule or rule number 2 of DUIS? So rule number 2, when the limits are functions of parameter and if I alpha, means alpha is a parameter here, equal to integration from a to b, where a and b are the functions of parameter f of x alpha dx, then di by d alpha equal to integration from a to b dabba by dabba alpha f of x into alpha dx plus f of b alpha db by d alpha minus f of a alpha da by d alpha, means derivative with respect to parameter, partial derivative with respect to parameter plus upper limit minus lower limit, means variable replaced by upper limit into derivative of upper limit minus same thing with lower limit, means variable replaced by lower limit into derivative of lower limit with respect to parameter alpha. So this is a rule number 2 and by using this rule I can find here equal to integration 0 to ax raised to n dabba by dabba x of integrand, means 2 by root pi e raised to minus t square dt plus variable replaced by upper limit into derivative of upper limit. So variable is t. So 2 by root pi into e raised to minus t replaced by ax raised to n square into derivative of upper limit with respect to parameter minus same thing with lower limit, means variable replaced by lower limit 2 by root pi e raised to minus t square, means now here it is a 0 into derivative of lower limit with respect to parameter. So definitely this value now becomes 0 due to this. Also dabba by dabba x, it means that partial derivative with respect to x of this bracket it not contains x, that is also 0, and therefore result I am getting d by dx left hand side as it is equal to 0 plus 2 by root pi e raised to minus a square x raised to 2n square of this into derivative of this with respect to x. So a constant and derivative of x raised to n is n x raised to n minus 1. So simplify this. So I am getting here d by dx of error function of ax raised to n equal to 2an upon root pi into x raised to n minus 1 into e raised to minus a square x raised to 2n. What we want to prove? So we want to prove same, that is the 2an upon root pi x raised to n minus 1 into e raised to minus x raised to 2n into a square. Yes, same thing. Now by using this we want to prove this. So ax raised to 1 here, this is our required result. Here we have to put n equal to 1. So therefore I am getting the result as d by dx of error function of ax equal to n is 1, so 2a by root pi x raised to 1, x raised to n minus 1, n is 1, so 1 minus 1, it is the x raised to 0, and x raised to 0 is 1, into e raised to minus a square, and n is 1, so that is why x square, and we want to prove the same, which is our required result. So note that normally when we have to take the derivative in the error function, we have to use the DUIS rule number 1 or 2, but normally rule number 2, Lebnitz rule. New example, show that d by dx of complement of error function of ax equal to minus 2a by root pi e raised to minus a square x square. So again it is a simple example. Why? Because derivative of error function or complement of error function means we have to use here DUIS rule number 2, that is the Lebnitz rule. So how? Let's see. Solution, d by dx of complement of error function of ax equal to d by dx of, what is the definition of complement of error function of ax? It is a 2 by root pi integration from ax to infinity e raised to minus t square dt. Same thing I can write d by dx of integration from ax to infinity 2 by root pi e raised to minus t square dt. So to decide the integrand, total integrand here, and then again the DUIS rule number 2. So what is the rule number 2 DUIS? That is the Lebnitz rule. As we know, this is the rule number 2, Lebnitz rule, di by d alpha. So by using this result, I can write here that is equal to integration from ax to infinity dabba by dabba x of 2 by root pi e raised to minus t square, that is the integrand, plus variable replaced by upper limit. So e raised to minus infinity here. Here variable is what? Here e raised to minus infinity. T is a variable and e raised to minus infinity is 0 there. So that is what upper limit, or for upper limit it is 0 minus now lower limit. So variable replaced by lower limit. So 2 by root pi e raised to minus, so t replaced by lower limit ax square into derivative of lower limit with respect to parameter. So that is equal to, here partial derivative of this with respect to x is what? It not contains x, and therefore partial derivative with respect to x is equal to 0 here, and therefore result becomes d by dx of complement of error function of ax equal to 0 plus 0 minus 2 by root pi into e raised to minus a square x square into derivative of this with respect to x is nothing but a. So final result is there, d by dx of complement of error function of ax equal to minus 2a by root pi e raised to minus a square x square. What we want to prove? So we want to prove the same, minus 2a by root pi e raised to minus a square x square, hence prove. So this is your required result. So similarly many examples where you just see here derivative with respect to x or maybe the another parameter. So you decide the parameter, because one may ask here instead of d by dx d by dA. So that time a will be a parameter. So here d by dA. So I will consider there a as a parameter, right? Because this variable is fixed, but here two parameters, either a or x. So one may ask the same or similar type example as a d by dA of, and that is why if this type of example prove that 1 by x d by dA of complement of error function of ax equal to minus 1 by a d by dx of error function of ax. So how you find this one, d by dA of this one? So you find first d by dA of complement of error function of ax, and here d by dx of error function of ax, and then you multiply here 1 by x, here minus 1 by a, and you will get the both results are same. So you try for this one and you send your answer on this mail. So consider new example, that is to show that d by dx error function of ax equal to 2a by root pi e raised to minus a square x square, and hence find integration 0 to t error function of ax dx. So actually we already solved this example, that is the d by dx of error function of ax equal to 2a by root pi into e raised to minus a square x square. We already have this result by this way. Still I am solving here. So here first part I can consider it as a step number 1. So d by dx of error function of ax equal to d by dx. So by definition of error function of ax is a 2 by root pi integration 0 to ax e raised to minus t square dt, and that is equal to d by dx of integration 0 to ax e raised to 2 by root pi e raised to minus t square dt. So by DUIS rule number 2 means Lebnitz rule, I am getting here integration 0 to ax dabba by dabba x of 2 by root pi into e raised to minus t square dt plus variable replaced by upper limit means, so here variable is t, so t replaced by upper limit into derivative of upper limit minus same thing with lower limit means variable replaced by lower limit into derivative of lower limit with respect to parameter. So here I am taking parameter as a x. So therefore 2 by root pi e raised to minus t square means t replaced by upper limit here ax square into d by dx of upper limit minus same thing with lower limit. So 2 by root pi e raised to minus t is 0, that is why e raised to 0 into derivative of lower limit. So definitely this term will becomes 0 because d by dx of 0. Also here it not contains x, and therefore derivative, partial derivative with respect to x is nothing but 0 here. So this term also 0, and therefore I am getting the result as d by dx of error function of ax equal to, this is 0 and only this term I am getting here. So 0 plus 2 by root pi into e raised to minus a square x square into d by dx of ax is nothing but a. So therefore result is d by dx of error function of ax equal to 2a by root pi into e raised to minus a square x. So by using this result, I want to find value of, I want to evaluate the value of integration 0 to t error function of ax dx. So step number 2 here. What is that? I want to evaluate integration 0 to t error function of ax dx. Same thing I can write here integration 0 to t 1 into error function of ax dx. Now integrate this by integrating by parts. So where u is this one and v is this. So therefore by integration by parts I am getting here first constant means error function of ax constant into integration of this one with respect to x is x, lower limit 0, upper limit t, minus integration of derivative of this one with respect to x is nothing but we already have the result. So derivative of error function of ax with respect to x is a 2a by root pi into e raised to minus a square x square into integration of this one is nothing but x dx. So evaluate this one now, simplify this. So how? So upper limit here t, lower limit is 0. So upper limit minus lower limit. So I am getting here error function of at because x replaced by now upper limit t into t minus lower limit. Due to this, I am getting x equal to 0. For the lower limit, value is 0. Now minus. Now simplify this one. So constant term you take outside. So 2a by root pi outside. Integration 0 to t e raised to minus a square x square into x dx. So by using standard integration, what is that? Integration of e raised to f of x into f dash of x dx, and that is nothing but e raised to f of x. So here whatever the f of x, if derivative is present here, then I can write directly e raised to f of x. So what is the derivative of this one? So derivative of this one is minus a square into 2x. But here only x. So I will adjust that. How? So in exam did not to write this step. This is only for our understanding. So I am taking here integration 0 to t e raised to minus a square x square, and here directly the derivative is nothing but minus a square into 2x. It means that minus 2x into a square into dx. So actually this x is there, but I am taking this one. So what is the additional here? Minus 2 into a square. So I will take here divided by minus 2 into a square, right? So simplify this, we'll get the answer. So that is equal to, I am getting now here, it is a t into error function of at minus 2a by root pi into 1 upon minus 2a square. How? So here the explanation. Into here e raised to f of x. By using this result, I am getting e raised to minus a square x square. What are the limits? 0 to t. And therefore, I am getting the result as integration 0 to t error function of ax dx, that is equal to t into error function of at minus minus plus. So now simplification, this minus minus plus, this 2 and this 2 get cancelled, 1a get cancelled, and I am getting here a into root pi. So now upper limit minus lower limit. So variable replaced by upper limit means x replaced by upper limit t. So I am getting here e raised to minus a square t square minus lower limit. So x replaced by lower limit 0. So e raised to 0 is 1. So therefore the required result is what? Integration 0 to t error function of ax dx equal to t into error function of at plus 1 upon a into root pi into e raised to minus a square t square minus 1, which is your required result. Similarly, many examples on the error function and complement of the error function you can evaluate. So here is one example, that is a find d by dx of error function of root x. So it is very simple, that is equal to, in short I am giving here answer, that is a d by dx of integration 0 to root x 2 by root pi e raised to minus t square dt, and therefore that is nothing but here by DUIS rule number 2 I can solve, it is 0 plus upper limit. So 2 by root pi, here e raised to minus t square means here I am getting minus x into derivative of this root x is 1 upon 2 root x with respect to x minus lower limit. So this is your answer. In short, I am going to find it, is it? But you know how to evaluate this stepwise, right? Just like the last few examples you can see. So with the new topic, we will meet in the next video.